Right now in space, there are 1,800 operating satellites, 2 designed to be serviced. The 1,800 operating satellites in space will be decommissioned at the end of their life and sent to a graveyard somewhere, either the ocean or further out into space. But now that new technology is bringing robotics and autonomy. We have the capability to go to different orbits with a robot, not a human astronaut, and service via robotically. If we are exploring the moon to find out what was the origin of our solar system, that's worth it for science, for humanity. To go refuel a communication satellite, maybe that's not worth it to risk an astronaut's life. And so, for that reason as well, let's send robots where it's dangerous or not worth it for humans, and let's save those precious astronauts for the really tough, the really meaningful missions.
So taking a quick step back, a bunch of satellites were sent out into space without the idea that they would ever be serviced or refueled. So then what happens to them?
So let's talk about this one. This is called Landsat 7. It was built by Goddard Space Flight Center. It was turned over to USGS, U.S. Geological Survey, and they operate it in space as we speak. This is a mock-up.
We've got a little mini. Can I pick this up?
And we've got one, yeah. So Landsat 7.
Got a little baby Landsat.
The instruments are up here at the top. The equipment to run it is down at the bottom. So in this part of the satellite is fuel tanks, batteries, a power system, communication. There are antennas here to send the data to the ground when it takes a picture. If we weren't going to service it, it would be decommissioned like all the other satellites in space. You ask, what is a typical life of a satellite? They launch alone, they operate alone, and then they're decommissioned, and if they're close to Earth, like Landsat is, it'll be sent into the ocean. If it's far, far out from Earth, they are sent further out into what's called the graveyard orbit.
It's space junk.
In the graveyard orbit, they become space junk. If they're close to Earth, we try to bring them in as close as we can so that they re-enter the atmosphere and burn up, and they're not space junk. But for lots of reasons, we end up with a lot of space junk in space.
And imagine, these aren't cheap.
These are not cheap. The one you're holding is probably getting closer to just under $1 billion. Yeah, so if you've got $1 billion asset, it would be nice to have the option to extend its life with refueling or put in new technology.
Explain to me what you're actually doing here in this space. You guys are practicing this stuff right now.
So we're using this facility to develop hardware and then practice mission ops.
So when you're actually testing this stuff, this room looks a little bit different.
In space, when we're behind the Earth, we call that orbit night. And then we're next to the sun, it's orbit day, but we want to be able to practice in orbit night, where the only illumination of our client is from the lights that we bring to the job, right? You're going to work on your car in your driveway in the middle of the night, you're going to bring a flashlight. So these are our robotic space flashlights illuminating the work site so that we can work. So we want to practice in as realistic an environment as we're going to have in orbit so that we're not surprised when we get there.
So we have the satellite over here, but all the other stuff.
That's right.
All the stuff that actually does things to the satellite is over here.
The first part of the mission where we capture, that's what we practice in this set. So the first part of the mission is actually the hardest, and that is getting 2 space vehicles together gently when the first one is traveling 16,500 miles an hour. Here's the hard part. The arm goes out, and it is going to autonomously, no human controlling the arm, it will control itself to reach out and grab the back end of the satellite. So it's on the rocket, the rocket shoots into space, and then a special signal is sent to release.
Ooh, let's go, okay.
And this floats away, and there you have Landsat 7
there it is, okay.
floating in space. Now, because that ring is nice structural metal, we're going to take advantage of that as a handhold.
And it wasn't made for that, but you realized that was the best place to grab on?
We realized that was the best place. So we want to grab the ring. So what we do in this cell is We practice autonomous robotic capture. We will put this satellite into motion. You see it's on this motion simulation platform. So we put it into motion as if it's floating in space. The robotic arm, not controlled by humans, but controlled autonomously by a camera out at the end, watching the client float in space. And so here's where we practice space contact dynamic. Roughly 8,000 times globally, we've abandoned our hardware in space because it ran out of gas.
So just how revolutionary is this technology?
It's going to open up a new era. We are on the cusp of a new era where space becomes more profitable. We get more utility. We can collect more science. We can explore farther. We can travel faster. We are on the dawn of a new era in space travel, space commerce, using space to help monitor our planet, to help unlock the secrets of the universe. And we are incredibly proud to be helping to provide the tools that will enable all these new capabilities.
Hey, NBC News viewers, thanks for checking out our YouTube channel. Subscribe by clicking on that button down here and click on any of the videos over here to watch the latest interviews, show highlights, and digital exclusives. Thanks for watching.